Hello, Assalamu alaikum to everyone.
Yes, please carry on.
I am Muhammad Imran, student of MSc Honor Agri Engineering from University of Agriculture, Faisalabad. So first of all, thanks to all conference committee member. Today my topic is impact of climate change on groundwater resources and adaptation strategies in arid zone. Author is Muhammad Imran. Outline of my topic is introduction, problem statement, objective and methodologies. Introduction. The agriculture sector of Pakistan is mostly reliant on irrigation water generated by rainfall and groundwater. The International Panel for Climate Change documented about 0.72 degrees centigrade temperature from 1951 to 2012. The IPCC reported as increase of 1 degree centigrade to 3 degrees centigrade till 2015, and from 2 degrees centigrade to 500 degrees centigrade till 2100,000, depending on the different gas emission circumstances. Pakistan is the third largest country in the world to extract groundwater. Approximately 9% of global water abstraction consumed and take of 4.6% total groundwater irrigated area of the world. Surface water ability for irrigation purpose is very low. On the other hand, the water demand is very high. Farmers extract the groundwater for crop growing during Kharif 2022-21. Waterability was maintained at 65.1 million acre feet, mild decline of 0.2% from 65.2 million acre feet in Kharif 2019 to 20. And Rabi season 2020 and 21 received 31.2 million acre feet, representing a 6.9% increase over Rabi 2019 2020. The problem is there the population of Pakistan is increasing in exponential trend, which leads to food insecurity. Due to this, the pressure on agriculture is also increasing, but climatic factors are not according to the needs of agriculture and recharging of groundwater. Due to less availability of surface water, low rainfall, high temperature, and crop water demand, the farmer has to extract the groundwater. This is the main cause of groundwater depletion in Multan. Objective of my research is the key objective of the current study are to analyze the trend of groundwater depletion using GIS, to analyze the impact of climate change on groundwater, and to propose strategies for the future so that depletion of groundwater can be minimized. My study area is that the study is conducted in Multan, Punjab, Pakistan. The study area is lie in an arid region with an average annual maximum temperature of 32 degrees centigrade and an average annual minimum temperature of 17 degrees centigrade, making it hot in summer and mildly cool in winter. In this region, the average annual rainfall is almost 7.3 inches. The required data for this study is gathered from several sources. The groundwater data is collected from two departments, soil and land reclamation department and irrigation department, Multan. The recorded data of tube wells in the Multan region is collected from the Pakistan Bureau of Statistics, and the rainfall and temperature and maximum minimum and mean temperature data were collected from the Pakistan Meteorological Department. Now data processing, the groundwater data were collected from 101 wells around the Multan at different sites from 2005 to 2020. The pointed data was fed into the GIS standpoint and the missing data points were interpolated using the inverse sampling method. The interpolated data were further disclassified according to the depth of wells. Our result is groundwater depletion. Groundwater depletion is frequently characterized as long-term water level reduction induced by continuous groundwater pumping. This study observed the groundwater depletion rate is 1.59 feet per year decline. The farmer at the upper side of the Multan region have taken more water from the canal as well as groundwater, but at the downstream farmer cannot easily uptake the surface and groundwater, and also downstream water downside farmer cannot take the good yield from the crop as compared to upstream farmers. This trend shows in 2004 high groundwater level is 65.4735 and 2005 66.1424. This trend shows the 1.59 feet per year groundwater depletion in Multan region. and the area irrigated by using canal and tube wells. This study compares the sowing area and irrigated area. The total sowing area is 481 hectares to 450 hectares, and the total area irrigated is 100 hectare to 444 hectare in 2009 and 17 respectively. The area irrigated by the canal is 4 hectare to 9 hectares, and the area irrigated by canal tube wells is 364 hectare to 400 hectare in 2009 and 2007 respectively. Sowing area is decreasing year by year due to urbanization on the cultivated area, and most of the sowing area is irrigated by tube well. Our groundwater level is also decreased simultaneously from 2009 to 2017 due to extraction of groundwater. Major crops in the Multan region is that wheat has a low yield of 17,090 and 19,000 tons and high yield of 20,466,000 tons from 2016. Respectively, each trend shows an increasing rate of wheat in Multan. And sugarcane has low yield of 31,324,000 tons and a high yield of 49,613,000 tons from 2010 and 2016 respectively. Each trend shows the increasing sowing rate of sugarcane in Multan. But the rice has a high yield of 3,643,000 tons and low yield of 3,425,000 from 2009 to 2016 respectively. Each trend shows the decreasing sowing rate of rice in Multan. Each trend showing the decreasing rate because of rice crop, more water required for growth. Maize has a low yield of 2,500 2,000 tons and a high yield of 5,237,000 tons from 2016 respectively. Each trend show the increasing sowing rate of maize in Multan, and cotton has a decreasing rate of in the Multan. This graph shows the trend of crops in the Multan region. Relationship between groundwater with climate parameters. This figure shows the relationship of groundwater depth with climate parameters such as temperature and rainfall. It is observed that the temperature is increasing with time. When the temperature is increased, then rainfall is decreasing due to occurrence of low rainfall. The groundwater depth increase with time. The monthly average temperature in Multan shows a clear season cycle from 90 and 2021. An increase in temperature reduces the chance of rain. If the earth is moist or there are hot deposits of water nearby, an increase in temperature then allows more water vapor to enter the atmosphere. Temperature affects rainfall in different ways. For example, high temperature can result in a very high rate of potential evaporation and minimum rainfall in some conditions. There is uncertainty in the rainfall rapid due to temperature changes. Therefore, the percolation is affected, with result is less depletion of water in the ground. We see at the start and the end of monsoon season, the water depths were 38.02 feet and 37.71 feet in 2005 respectively. At the start and end of monsoon season, the water depths were 50.06 feet and 50.24 feet in 2020 respectively. Discussion the strategies that are made for future trend for groundwater recharge and to minimizing groundwater depletion are correct choice for cropping pattern according to water availability and agricultural zone. Metering system over tube well. First one, and the second one is installation of recharging wells. Third one is engineering survey before installation of tube well to see the area of influence of every tube well. The fourth one, the use of precise irrigation practices instead of traditional practices. Sixth one, the farmer awareness is also necessary so that they are tend to use modern concept for farm mechanization, for example, drip, sprinkler, bubbler, lateral methods for irrigation. For this example, seminar, Kisan Mela, webinar, workshops, and advertisement of modern technology are necessary. Conclusion of my study is in this study, the groundwater is rapidly depleting, yet charging does not occur at the same rate to balance the entire system due to the effect of climate change, such as variable rainfall and global warming. The result of this study showed an association between climate change and the depletion of groundwater. In this study, specific strategies are proposed to increase groundwater charging and reduce the impact of